All right, what is the process for division of fractions? Let's review. What do we call that? Declan.
I know how to do it, but I don't know.
Okay, that's all right. Macy, copy dot flip. Go ahead and write that into your notes. Okay, let's go ahead and solve these problems really quickly. We've got 4 of them. 3 of them, sorry. Take about 15 seconds to solve those. Cecilia? Okay, I'm not ready for the answers yet. Come on in, guys. Okay, how about the first one? 3/4 divided by 4. What'd you get for that one, Mendel?
I got
Nice job. How about the second one? 3/5 divided by 1/5. Cecilia, what do you have? It's not gonna be 3/25. Let's write the second step down. 3/5. We're gonna copy, dot, and then flip. Really, we should have 3/5 times 5/1 because we're flipping that second fraction. These are gonna cross cancel, and we're gonna end up with what, class? 3. Good. Okay, how about 2/3 divided by 1/4? What'd you end up with for that? McKinley. Well done, 2 2/3. Okay, let's do some word problems. Yay. It's my favorite. They're so fun. I like word problems. Oh, Ashlyn, you can do a grade correction and follow the procedure, put it into the missing work, okay? So put the little sheet, make sure it's filled out into your workbook, put your workbook in the basket. All right, Jerome has 3/4 meter of ribbon. He cuts the ribbon into equal pieces, 1/8 of a meter long. How many 1/8 meter long pieces of ribbon does Jerome have? We're gonna start with a bar model. How many sections should I divide my bar model up into if he's got a 3/4 meter ribbon? Landon?
4 sections.
Yep, I'm gonna divide it up into 4, and then I'm gonna label it 3/4 of a meter. Okay. He wants to cut that 3/4 up into 1/8 meter long pieces. Well, how many meters are each one of these sections, you guys? Piper? Yeah, they're each a 1/4. So is it going to be pretty easy to go from 1/4 to 1/8? Can someone tell me how to model that? I'm trying to change colors, but how would I model that, Piper? Yeah, I'm just going to subdivide in half for each of those sections. All right, and then this is the 3/4 that we're starting with. How many 1/8 long meter pieces did he end up with? Just look at the bar model. Don't even do the math right now. Tommy? 7? Let's change this to 8s. 3/4 equals how many 8s, Tommy? 6/8. How many pieces did he end up with? Yeah, he ended up with 6. Let's go ahead and do the math. What we just did was we divided 3/4 of a meter by 1/8. Our question was how many 1/8 long chunks can we get out of that 3/4 meter? So our math looks like this. 3/4 times 8/1. We'll go ahead and cross cancel because we can and it's fun. There we go. And our answer is 6 1/8 meter pieces. All right, I want you guys to practice adding the labels today. Make sure you're adding those. You're gonna have questions on your homework today where you're like, how many 1/10 pieces or how many 1/8 pieces? And so it's important that you guys label these properly. This is the way I like, just put a semicolon or a colon between them so it doesn't look like it's 6 and 1/8. Okay. Uzziah,
Didn't you say like Jerome cuts whatever
like in a
then
complete sentence,
Yeah.
you can do that. Yes. Shafiq,
We get 1/5. How do we get 1/5?
1/5, I have 1/8. I think it's just your perspective. It's a combination of your perspective and the pen. But it says 6 1/8 meter pieces.
Need an E.
There's an E, it's just, there you go.
Oh, I think that was a C.
All right, let's go on. Hillary has 9/10 of a liter of cooking oil. She pours them into 1/20 liter bottles. Find the number of 1/20 liter bottles of cooking oil that Hillary has. Let's start with our model. I'm going to make with this one a big one. Yeah, why am I making this so big, do you think? Probably because I'm going to have to divide it up into 20ths at some point. All right, if she has 9/10 of a liter, I'm going to do a better one. I don't like this part. How many sections should I divide my initial bar model up into? What do you think? Cameron? Yes, let's do 10. So I'm going to split it in half first, and each half will be split into how many sections? Yeah. So let's do 5 here. 1, 2, 3, 4, 5. 5 here. 1, 2, 3, 4, 5. That's a pretty even bar model right there. I'm proud of that one. Up for this. Okay, so let's go ahead and label what she's starting with. She's got 9/10 of a liter. So that's going to cover 9 of our out of our 10 units right there. All right. Now, if she wants to put it into 1/20 bottles, can I make those 10ths into 20ths pretty quick? What should I do? Morgan? Split them into half. Yeah. I'm going to go ahead and subdivide each unit into 2. And now I have 20 units in my whole, but she doesn't have that much cooking oil, does she? How many 20ths does she have? How many 20ths does she have? Owen? She has 18 20ths, exactly. And you can see that from our bar model, right? Well, here's our division problem. We just took 9/10 of a liter and we divided by 1/20 of a liter. When we copy dot flip that, we're going to copy that first fraction and we're going to flip the second fraction on its head. And we get 18 1/20 liter bottles. Okay, pretty easy, right? Let's go on. Tiffy? How do I get 1/20? Okay, let me back up. So she started out with 9/10 of a liter, right? And so you can see the blue units here are 1/10 liter intervals. We split our initial bar model up into tenths. She had 9/10 of a liter. She wanted to split it. She wanted to pour that 9/10 of a liter into 1/20 liter sized bottles. So we need 20ths. So we could tell that we could easily split our tenths into 20ths just by subdividing each unit into 2. Now that gives me 20 units for my whole, but she didn't have quite that much oil. She had this much oil. Once we split those into 20ths, that was 18 20ths. Okay. My division problem was right here. We divided 9/10 by 1/20. This is how we modeled it. This is how we performed the math. Okay, does that make a little bit more sense? Okay. Okay, let's keep going. We've got some more problems here to work with. All right, Blake has 3.5 meters of string. He cuts the string into 1/2 meter pieces. How many pieces of 1/2 meter string does he have? All right, so here is our 3.5 meters right here. I've already got some units drawn in there from last year. If we're gonna cut that into half meter pieces, you can see I've got my units divided, my 1 meter pieces divided up into half, right? And that's this bar model down here. We wanna know how many 1/2 meter long string pieces he has. So our division question is right here. We've got 3.5 meters divided by 1/2 of a meter. I bet you guys can tell me without doing any math how many he's gonna have. How many is he gonna have? Carter. He's not gonna have 4. 7. Where was the 4 from? Okay. Uh-huh. Okay. So then you just add that, but you forgot you have to multiply the 3 by 2 also. Yeah, so since you're on that like line of thinking, let's go ahead and use distributive property for this. So we would have 3 times 1/2 and 3 times 2 plus 1/2 times 2. So you would get 6 and 1, which would equal 7 half meter pieces of string. Okay. All right, let's move on. Sierra brought 2 1/2 kilograms of flour. Packs the flour into 5 12 kilogram bags. How many 5 12 kilogram bags does she have? Okay, why don't you guys go ahead and try this one? Then you can go ahead and move on for the next couple of Toyos that you have as well. But, Piper, can you read it out loud, please? Great. How did you set this up?
So I did 2 1/2 divided by 5/12.
Okay.
So then I flipped the 5/12 over to 12.
Okay. Could I ask you, did you do this with like, did you use an improper fraction or did you use distributive property?
Yeah.
Okay.
I used an improper fraction.
Okay, so you did 5 halves and then times 12 fifths.
Yeah.
Like that? Okay, awesome.
And then so yeah, I canceled those out and then made that 1 and that a 6. So
Nice. And that would equal 6 5 12 kilogram bags. All right, nicely done, Piper. Thank you. Let's go to the next Toyo. First of all, let me circle back. Are we all okay on this one? Anybody else want to go back? Anybody want to go back over it? Or are you guys good? You're good. Okay. All right. Jake buys, well, there's your answer. Jake buys 4 2/5 liter of milk. He pours all the milk into 3/5 liter containers. How many containers are completely filled? Okay, that's a key word there. What fraction of the last container is filled? How did we set this problem up right here? McKinley? Okay, 4 2/5 divided by 3/5. Then what'd you do? Okay, so you had 22/5. And then did you do copy dot flip? Okay, then times 5/3. And then did you cross cancel those? Okay. You got 22/3, then what? Okay. 7 1/3. Now here's the thing. It says how many containers are completely filled? So what's the answer to that question? 7 containers. And the portion of the last container was 1/3. Okay, that's going to be important. You're going to have a homework question kind of similar to that today. So I'll talk about it when I assign homework, but. All right, and then we've got this one. How many times is 5/6 as large as 1/3? Okay, this is a division question that we haven't come across yet. But remember how we talked about how division is the inverse of multiplication, right? This is asking you a backwards multiplication problem. It's asking you, by what number would I multiply 1/3 by to get 1/5/6? That's really the question, but it's backwards. It's like asking you, how many times is 8 then 2? How many times is 8 then 2? Just like, that's a math fact, right, guys? It's 4 times as much, right? It's the same question as saying, how many, like, by what number would I multiply 2 by to get to 8? Does that make sense to you guys? It's kind of hard with fractions though, because then we've got the fraction in there and the question gets all muddled and it's tough. So when we set this up, how many times is 5/6 as large as 1/3? Is 5/6 as large as 1/3? So that's really 5/6 divided by 1/3. Just like when I asked you the question, how many times is 8 as large as 2? And you told me 4. That's because in your mind you divided 8 by 2. All right, so this is our division question right here. So that's going to equal 5/6 times 3/1. How many people got this one? Did anybody have a hard time with the setup? Like knowing which, okay, good. Wait, what did I just do? There we go. I cross cancel, but I did not cross cancel correctly. So what's my answer, Mira? 2.5, good. Okay, that last Toyo we're gonna forget about. Do you guys have the one that's like Todd reasoning and all of the models? Oh, good, we took that off. It was not a great problem. Okay, so let's get out your workbook. We're gonna talk about the assignment for tonight.